Hello and welcome. My name is Thomas, and in this episode I'll be going over my solution for challenge number 5, determining the compromised system. In previous episodes we determined what account was compromised, what tool the attacker used for that purpose, or to dump the domain hashes, and then now we're going to be looking at what the IP address is for the compromised system. So we can talk to Sparkle for a hint, so let's do that first. So issues with this Christmas cheer laser, and we need to help fix that. And to do that, we're going to be using PowerShell commands. So let's start out by reading what's in home calling card. Okay, let's see. Could commands hold riddles in the history? So let's look at the command history. To do that, we can use get history, and I'm using this additional command basically to make sure we have the full output. I have many name value variables that I share to application system wide. Add a command that will reveal them as secrets once you get my child items. That's for in a bit. This is what we need to look at first. That's our first value, angle, which is 65.5. Next up, obviously, we have environment variables. So grab those. Let's get child item nth, and again make sure we have the full output. There is a riddle environment variable which gives us some information on where we need to be looking next. So we need to go through the /etc or /etc folder and then sort by last write time and reveal the most recent file. So we'll be piping some things together here. First off, get all the child items of type file in /etc. Then we pipe that and we sort by last write time and only keep the top one result because we're only interested in the most recent one. And then for that entry, we're going to be showing the full name and the last write time. There's an error here, but that's fine. That just means we don't have read permission to that particular folder or file, so we can ignore that. What we're looking for is this particular file, which is an archive, and this is the last write time. So we start by opening up that archive, or expanding it, expand archive, and then we're going to do that. We're going to move it or expand it into our home folder. Wait for that to finish. There we go. We have a refraction folder, okay. Hopefully we'll get a refraction value out of that. And in that folder, there is a riddle file and a runme.elf file. Now, elf binaries are executables, so we should be able to run this, but we can't. And the reason why is because it is not executable. We are running on a Linux system. This is PowerShell core running on a Linux system. So let's make that file executable first by running the appropriate Linux command for that, which is chmod u+x, which means execute permission for the user, and then the name of the file. Trying to run that again, and now it executes, and we get the refraction value. That's parameter number 2. Now, there was a riddle file in there as well, so let's get the content for that riddle file. There we go. And very shallow, am I in the depths of your elf home? You can find my entity by using my MD5 identity. So we need to look for the file with the matching MD5 hash. So again, going to go over our home folder this time. Again, recurse over that, get all the files. And then for each of those, we're going to be calculating the MD5 hash by using get file hash, and then with the algorithm MD5. Then we're going to compare those values and just keep the one where the hash value equals the value we're looking for. And finally, we're going to be showing the path to that file. So execute that. Looks like that is not what we... Oh, then that's obviously supposed to happen because I'm still in the refraction folder and we need to look through our home folder. So moving up 1 and running that again. Nah, that's better. There we go. That's the file I need to find. So again, same thing as before, get content, copy that in, and we have the temperature value. So that's 3 parameters done. We have one more left to do, which is the gas mixture. So next hint, I am one of many thousand similar texts contained within the deepest of home elf depths. Finding me will give you the most strength, but doing so will require piping all the full names to sort length. So we need to find the file with the longest path, basically. So again, we're going to recurse over our home folder. I mean, the current folder in this command, but since we're in the home folder, it's going to be the home folder. We're going to be selecting the property of each of those things that we find, which is going to be the full name, because that's what we're interested in. We're going to be sorting on that property by its length. And we're going to be selecting the last one, the one with the longest value, basically. And just to make sure that we see the full output, because it is going to be a long string, again, I'm going to make sure that we have some room to do that. Wait for that to finish. And there we go. So that's the file we had to find, hopefully. Again, get content. And paste in this very long file path. There we go. Next up, get process information to include username identification, and stop processes to show me you're skilled, and in this order they must be killed. So we need to find the processes, or list the processes basically, and make sure we have user IDs or usernames in that output. For that we can use get process and then include username. There we go. And now we need to kill the processes in the order of Bushy, Alabaster, Minty, and Holly. We can use stop process ID for that, or stop process rather, tag ID, and then we start giving the ID number for the process. So Bushy is going to be 23, Alabaster is going to be 26, Minty is going to be 27, yes, and then Holly is 29. And once that's done, we should be able to access a file named /shal/c. So get content again. Shall see. There we go. Next up, still no gas mixture parameter, so we'll continue on. Get the XML children of /etc and an event log to be found. Group all IDs on the last thing will be the properties of the lonely unique event ID. So what we need to do first is find the XML file in the etc folder, basically. So we can use a single command for that, which is this: get child items for /etc, include XML files, and use recurse to go over all the subfolders. Again, same error as before. We don't have read permission to that particular location, but that's fine. But we do find an event log.xml in this particular path. Now, what we need to do first is group all the IDs in that XML file, and there's going to be one which has a unique ID. So we need to determine that first. So to read the XML file, we can use import CLI XML and give it the name of the file. Then we're going to group the data within that file by the ID property. Then we're going to sort that in descending order. And hopefully we'll have one entry that is all by itself. And there is the item with ID number 1. There's only one for that, so that's the one we're looking for. So next up, we need to look at what that event looks like, what that entry looks like. So we're going to do the same thing again, import CLI XML to read that file. And then we're going to add this portion, which basically says, well, give me the entry where the ID equals 1. And that gives us the output, where in the message portion, we'll see the correct gases post body is what we need. So now we have all the information we need to correctly configure that laser. Now to do that, I'll scroll up all the way to the top. We can use web requests to this particular URL to set all of these different parameters. Now, the first thing I'm going to do is I'm going to shut down the laser. I'm not sure if that's necessary, but honestly, I'm not messing with live lasers as I'm tweaking parameters. So I'm going to shut it off first by making an API call to the API off API endpoint. So that's done. Next up, I'm going to configure the angle. So we're going to make a GET request to that particular API endpoint, which is angle, and give it the correct value. And we say we get some output saying updated mirror angle. Perfect. Next up, we have our refraction value. So enter that, same thing, just a different API endpoint called refraction this time. Again with the correct value, hopefully the correct value. Can't say for sure. We'll see what happens once we check the output. And then temperature as well. There we go. So that is done. Now the difference for the gas mixture is a little bit different, because to set that we need to do a post request, not a GET request. So first what I'm going to do is I'm going to set that correct gas mixture as a value for this particular variable. So that's done, and now I can submit my post requests by specifying a method called post and specifying that variable that I created earlier as the body of that post request. So there we go. And that's done as well. Now, since I've shut down the laser for safety reasons, I'm gonna start it up first. So turn that back on. And now I will check the output. And awesome, we needed to have 5 megajoules of laser output per liter, but it looks like we have 6.49, which is pretty cool. Awesome. So that is done. So let's see what Sparkle has to say. Look at Zeek logs. Rita can help us out. So we have an additional hint for Rita. Okay. So look at the hints. Let's see, Rita from Sparkle Redberry. Let's see what Rita is. Okay, so Rita is an open source framework for network traffic analysis. Okay, cool. That's good to know. So let's go back to our objective, determining compromised system. The attacks don't stop. Can you help identify the IP address of the malware infected system using these Zeek logs? Now, if you look at the Zeek logs, when you download them, they basically contain a static version or static output from the Rita tool. There's no need to install Rita. You can obviously do that if you're interested in it as a project, but the difficulty rating doesn't really require you to do so. There's a static version of that output in there. So if you go and look at what that looks like, if you open it up from the Zeek logs folder, you can go into LView, and there's a different number of sections, categories at the top here. One of the things that happens when you have a malware infected system is it beacons out to a command and control server, both to report information and to retrieve new instructions on what to do next. And one of the things that Rita allows you to do is look at specific information about beaconing. Rita will actually go through those logs, assign a score related to beaconing, and the higher that score is to 1, the more likely we're talking about actual beaconing or malicious beaconing activity. And so in this case, on the beaconing tab, the scores are sorted in descending order. So the top one is actually the one that's closest to 1. And with a value of 0.998, in all likelihood, that is probably going to be beaconing activity. And so the source IP address for that is 192.168.134.130, and is most likely the system that's compromised. Now, another location, another tab you can look at would be long connections, where that IP address is also listed as a top hit for having the longest connection. So those two things kind of hint at that IP address being the one that was compromised. We also have the destination IP, which gives us the IP address of the command and control server as well. For now, let's copy out that source IP address and paste that in and see if that's correct. And it is. Awesome. Now, the difficulty rating, I think it's more about the combination of the hint and the actual challenge itself, because the challenge itself obviously wasn't that complicated. But in all honesty, I did learn quite a lot in terms of PowerShell. Spent quite some time on the Christmas cheer laser hint myself for this. Anyway, that's it for this episode. Hope to see you in the next one. We'll be talking to Santa, and hopefully he'll be giving us some more challenges to continue on. Thanks for joining. Have a great day. Bye.